All right, our seventh one comes to magnesium and fluorines combining together. Now remember, here's the thing that's tricky if you're not paying attention. If you're just looking at the F, remember that 2 right there, remember it tells me I have to have 2 of these atoms. So if you're just doing this, you're going to have a hard time because you're not going to be able to figure this out, right? Remember that F2, that 2 represents I have to have 2 atoms right here, right? So I have to have 2 fluorine atoms. So I really have 3 total atoms that are going to combine together to make this molecule, all right? So regardless of whether I had 2 or 3 or 4 or 5 atoms, I'm always going to start it off the same, which is, right? Let's go over to here, periodic table, figure out how many valence electrons in my electron dot diagram. So Mg right here is there. So it's in the second column. So I know it's going to have 2 valence electrons. Okay. Fluorine. It's over here, right? So since it's 8 and it's in the 7th column, each one of my fluorines is going to have 7 valence electrons. So let's put 7 valence electrons around, right? Now, regardless of whether or not, right, these, there's 2, 3, 4, 5, it's still the same. We still need to figure out which ones are the givers and which ones are the takers, right? So the rule of thumb is always going to be, is it going to get to 0 or is it going to get to 8? I think that's right. Let's push these down a little bit so that way you can see it better. Okay. All right. So magnesium right here, right? In order to get to 0 or 8, it's going to have to, what, give away 2 electrons to get to 0, right? Or it's going to grab 6 more, right? It's going to take 6 more electrons. Magnesium is going to be a giver then, because it's much easier to get rid of 2 than it is to get 6 more, right? Fluorine, it's got 7, right? It's much, much easier for it to get to 8. So it's going to be a taker, right? Remember, in all ionic bondings, one type of atom is going to be givers and some are going to be takers. So in this case, even though there's 3, right, F's, right, they're both takers. Magnesium is a giver, right? Now, what does each one of these fluorines want? They want 1 more valence electron. Well, guess what? Magnesium has 2 electrons. So 1 electron goes to that one. That one now has 8 valence electrons. This one goes to this fluorine atom, right? Which means now that has 8. So now this magnesium is now, right, it's combined to both of these right there together. Okay, so now there's an invisible bond here. There's an invisible bond there that goes to that. So now, right, we know that, hey, guess what? These atoms have changed. So what do I got to do? What do I have to do? I have to show that they have changed, right? So they have to, I need a couple more over here. So I'm going to get one there and one here. All right, so I have to show that these atoms have changed, right? So I'm going to put that there, right, and there. So what now charges do they have? So magnesium lost 2 electrons. So now it's got a 2 plus charge to it because now it has 2 more protons, right? This fluorine gained 1 electron. So it's got a 1 minus charge because it's got 1 more electron now. And this fluorine, same thing, right? It gained 1 electron, so it's 1 minus, right? So, right, I know it gets kind of crazier with more stuff in here. However, 2 ways again, you can still double check. Number 1, this one has 0, right? Remember, you want to get to 0 or 8. So this one has 0. This atom has 8. This atom has 8. Perfect, right? Because I did that in that case. The other way to look at it is, let's look at our pluses and minus signs, right? I should, if this is done right, I should have the same amount of positives as negatives. So if I add these 2 negatives up, that should be 2 minus, 2 plus. So these all cancel each other out, which means I did it right. So this ionic bond is correct for magnesium fluoride. Cool? All right, let's move on to the next one.